Good morning, ladies and gentlemen. Out of two, good to have everybody here today, except Jax. I don't know what happened to Jax. But we're going to do something today called factoring. As you might recall, yesterday, for instance, we had a situation where we had problems like this. Find the product of two linear binomials, and we worked this out, and I don't know what you remember from yesterday, but the answer to this one is going to be x squared minus 25. Does that make sense when you work things out? Yeah, if you remember something from yesterday. Now in factoring, what we're doing is we're going the opposite direction. So what we do is we look at this thing right here. Instead of going, we're going to go in this direction and work in reverse. That's what we're doing with factoring. So you're taking, it'd be like if I gave you a number like 6, what would be the factors of 6?
3 and 2.
3 and 2. Okay, very good. And so in a similar sort of analogous way, we're taking a situation, and they give an example here, that they're saying 4x squared minus 8x. What we're doing is we're factoring out, we're trying to find something called the greatest common factor as GCF. Have you ever heard of that before? Yes. Remember that from Algebra 1 back there? GCF, greatest common factor. And so here they give us kind of an example problem. This one right here, you have 4x squared minus 8x, and in the factoring process, finding the greatest common factor is going to be your first step. You don't want to do anything else first. And so you look at those two terms, and these things right here, separated by plus and minus signs, are called terms. Okay, terms are things, and these things are what they call monomials. Why do we call these monomials, each of them? Just one, right? And what it is, these two monomials separated by a minus sign, together they compose a binomial. What kind of binomial is this called? A what kind of binomial?
Did you say it?
Pardon me?
Did you say it, like what it's called?
No, I didn't
Okay.
today yet. What kind of binomial do we call this? It's, how we call the binomial is dictated by what this thing here is.
Oh, square?
Almost, right? But you call it a squared binomial, but usually we call it a quadratic binomial.
Oh, yeah.
Okay, so you remember that? Okay, good. And so we have a quadratic binomial, and here we have, quadratic monomial, excuse me, and this one right here is what kind of monomial? What's the one lower down? Yeah, regular, but it starts with the word starts with an L. A linear binomial. So you got a quadratic monomial minus a linear monomial. Together, they are a quadratic binomial.
That's interesting.
All right. So just some vocabulary review, I hope. And so you look for the numbers and letters that are in common between these two. So if you look at just the numbers, like the 4 and the -8, between 4 and -8, what's going to be in common as a factor between those two?
2.
Well, actually, the common factor between those two is 4. Because 4 is a factor of 4, and 4 is also a factor of -8. And so we just write that over here, and now we look at the variables here. And so we have x squared here and x, so between x squared and x, which is the greatest common factor between those two things? You have x squared and x, what's the greatest common factor between those two things? Yeah, so who said x? Somebody said x over here, right? Okay, yeah, x, yeah. And so now what you do after you write those, we've taken out the greatest common factor, and then you parenthesize out here front, and you say, okay, now you look over here, you say, you ask yourself the question, what times 4x equals 4x squared? Because we're trying to reverse distribute. We're finding what number do we have? Well, it'd be just x, okay? So we can check our work, because 4x times x is 4x squared. And then we know we have a minus sign here, so we know we got to have a minus sign here, right? Mm-hmm. So what times 4x is equal to 8x? True. Somebody said hesitatingly 2, but that's right. And so now, and so you can see now, if we multiply these back together, we're going to get this, right? Mm-hmm. And so this is what's called a successful factoring of this. So what we have is yeah, this one here, they actually got it wrong in the example. Look at that. This is wrong, okay? This should be 2 over here they have. Okay. All right, this is binomial. X minus 8 is not a binomial factor of that. It's x minus 2. It's 4x. Yeah, see, if you multiply this back together, you'll get 4x squared. They got that right. But then you'd have minus 32x. So they messed this up. Okay. Anybody else catch that? No? You did? No, you didn't. Okay, that'll give me something to say for next class. Second period class, do you see something wrong with this? See if they can get it. Okay. So anyway, that's the basic process of it. Do you have any faint remembrance of familiarity about this somewhere?
No.
Back in your resources of mind? Because somebody, you told me you heard before what a greatest common factor is. If you heard what a greatest common factor is, you had to have looked at something like this at some point.
Honestly, I don't remember anything from my class except for certain words.
Okay. All right, so that was a word you remembered.
Yeah, like I remember
Okay.
Grace coming back here. I remember.
Well, that's what you're addressing now is one of the reasons we have our little song, right?
Yes.
But Algebra 1 has been so long, and that's why my teacher sings this song, because when he saw my work, it was all wrong. So anyway, that's it. So we've forgotten a lot. Maybe we didn't learn it well the first time. So we're going to go over some exercises today on this and just try to work our way in. Get back here. Does this look like it's very hard though?
Yes.
It does?
There's a lot of steps.
A lot of
So we're
steps?
just technically doing the opposite.
Yeah, we're doing the opposite direction. So if you kind of think along those lines.
Oh, I lost.
And the one thing about this that I think makes it pretty easy, that's pretty easy to test your work, because if you just multiply them together, see if you get where you started, and then if so, you've done it right.
We're just need to stop today.
I might have to do this one here, because that's sort of an ongoing feature of the class. What I'll do is
I got it.
I'll take attendance.
Someone get Abraham and give it back to you.
I really don't know what to do after that.
Yeah.
You do the chapters or whatever.
I zone out literally 90% of the day. I'm just out.
Look at number 2.
Oh, wow, that's big. What is that? Just
I did it. I did number 1.
I hate.
Like literally.
Like this. I do that all the time. Or I used to do that all the time. I do that all the time.
Yeah,
You ready to start our video?
There you go.
Thank you.
You're welcome. Hope you feel better.
References that? Just go over there. And then over there. And then I think the angel, she's like, yeah.
Did you get the yesterday's class video out to you via remind? Exactly 5 p.m. Okay, good. Good. I want to check on this.
Are you
What is he talking about?
We're the Vine video. The one you're supposed to get at 5 p.m.
Okay.
on the dot.
Yeah, and I might send it out between 5 and I'll try to send it out between 5 and 5:30. I'm going to try to send it at 5 o'clock for this class, and I have slightly different times for my other classes.
Like after 12, they're just like, I'm going to tell you what time it is right now. You're just-
Okay.
You wouldn't even understand.
I don't even know.
It's basically.
Okay, let's go on to this one right here.
You know where.
Oh.
Okay, so we look at these things right here, and this is very similar to the one that the book got wrong on the first one. So right now, just looking at these two things, we have these two terms, and this is again a quadratic binomial, just like the example problem they gave us. And so now, first looking at the numbers between 9 and 18, which one of these, what is going to be our greatest common factor between those two numbers?
I have 9.
Yeah, so if you said, now there are other factors, there's 3, right? 3 is a common factor, but 9 would be a greater common factor because 3 is a factor of each of these, but 9 is better because 9 will actually wipe this out and then wipe out half of that. So we got 9, and now between a squared and a, what's going to be a common factor between those two things? A. Okay, so we put A, and so now we go like this, and then we question ourselves, what times 9a is going to equal 9a squared?
Squared.
A. And then we know this is a minus, so that's going to have to be minus here. And between, for the numbers, okay, what times 9a is going to be 18a? 2. Okay, and then, so if we multiply, and now we can test it, right? Because if we multiply these back together, we should get 9a squared, right? 9a squared. And then negative 2 times 9a minus 18a. So does that check out? Yes, it does. So this, therefore, is our correct answer.
So that's like this. Wait a second, that's the exact same thing as the problem.
That's right.
What?
That's what I was explaining.
You're trying to change this into that while making them.
Yes, well, go ahead there. Yeah.
That's observation.
So I kind of went ahead a little bit, right?
I'm thinking of
And
the red
I-
is the answer to the
That
answer
goes
to the
from 5
question.
to 12.
Shut down.
Yeah, we'll get to that later. That happens sometimes, so that's a good example.
Last week we feel really stupid.
So we have Lillian who's working ahead. Anybody else working ahead like Lillian on these?
I was yesterday. No.
Not on this? Okay, Lillian looks like she's working ahead on this. So that being the case, what I'm going to do is,
How are we gonna do number two?
I'm going to go to problem 2 here.
I can't.
And I'm going to let Lillian help us with problem 2.
Okay, thank you.
So she's,
That's what happened.
you didn't do number 2?
But she got number 1.
Which one did you do? What's the first one you did?
I did 11 and 12.
Was it 11? Okay, so let's go to 11.
Bruh.
I'm fine with that.
Bruh.
All right, so now we're to 11. So Lillian's gonna help us out with number 11.
Okay, so the common factor between the two is, well, there's no common factor, it's just the 5. The first one doesn't have the number,
Okay,
so, okay. So it's x, then parentheses, then x squared,
okay,
and then minus 5x.
that's 5x, okay. Now this is a factoring, right? Now this is an example of factoring, but this is one that I would call not completely factored. Because you can see that if you actually distributed and worked backwards, you would get to the original thing, right? But is there something she missed on there? I'll state it differently. There is something she missed on this, and what did she miss? She didn't go.
5x squared.
Pardon me?
5x squared. Right.
No, it's 5x squared if you multiply x.
Okay.
Oh, yeah, how
She's
that
missing something.
The first x should be squared.
Yeah, so I think maybe Mason has figured it out. You can correct me if I'm wrong. So if we take instead of factoring out an x, let's factor out the x squared instead,
Oh.
right?
Okay.
Because x squared is a common factor to this and to this. So this x is a common factor, but this x squared is what we would call our greatest common factor.
Yeah.
Okay?
You see it?
So what we're gonna do now is, so now having done this, how does that change things for us, Lillian? What are we gonna have instead here?
It just becomes,
X, right?
yeah,
X and
and then minus 5.
minus 5. Okay, so this would be it. So I want to give credit especially today to Lillian and Mason on this
Oh, yeah.
for doing some great work. You guys did some great work, I have to say. Okay?
Oh, yeah. It's just
Okay, now I want to retract back to problem 2. And if you look back at problem 2 has a lot more stuff, doesn't it? And so what I want to do is just, I want us to get the idea that it's not something to be intimidated about. Okay, because if you take this thing one step at a time, it shouldn't be hard. Okay, now between 16 and 32, what's going to be our greatest common factor between those two things?
16.
16, okay? So next we look at we have a to the 5th and a to the 4th. What's our greatest common factor between those two things? Yeah, it's going to be a to the 4th. Because a to the 4th is a common factor of this, and it's this whole thing here, right? Okay, now between b cubed and b, what's our greatest common factor between those two things? B. And so now we've factored out, so this looks to be our greatest common factor between those two terms. Okay, Kaylee, you have just a great expression on your face, the expression of wonderment. You just have a very expressive face. Are you an actress?
Yeah.
You are? You have really, like you're in the theater? Okay, wow, well that's good. You just have it. Whatever's you have it. So what is puzzling you?
I'm sorry, what did you say?
What is puzzling you about this?
I don't think I'm impressed. I'm just like really totally and truly lost. I don't know why.
Okay, well, I'll tell you what I'll do. What I want to do is I want to finish this problem, and then I'm gonna sort of break down maybe a more complete explanation here to the right after that. How's that?
All right.
So now we look at this thing right here, and what times this is going to equal this?
5.
Well, we need to have a to the fifth, right? So we need a still, don't we? Because now when we multiply this, we'll get a to the fifth. And what times b is going to be b cubed?
B cubed.
B squared.
Oh my God.
Okay? And so now we have that. We have a plus sign here, so we know this is going to have to be plus here. So what times 16 is 32? 2, right? And what times a to the fourth is a to the fourth? 1, right? So we can just leave that alone. What times b is equal to b? B, right? So literally that's it.
That's it? Oh, thank God.
So if we multiply these back together, I hope you can see, if we multiply this by this, we're going to end up with 16, excuse me, I put 16 there. We'll end up with 16 a to the fifth b cubed plus, and we just have this 2 times the 16, everything else is the same. So we have 32 a to the fourth b. And so this checks out, so that's our answer. Now, just kind of backtrack a little bit. What I want to do is rewrite these expressions sort of in a longer form. And one way of looking at this is we know that 16, but these A's here, you got 5 of them here. A, is that right?
Yeah.
And then you have these 3 B's here, you got B cubed, right? Okay, and then you have plus 32, it's pretty long here, I'm going to, right here. We have 4 of these A's, A, and then 1 of these B's. And so what you're looking for is what they have in common. Well, we know that between this 32 is a product of 2 and 16, right? And so 16 is in common, and we have 2 left over, and then we see we have 4 A's here. You look for one with the less. We got these 4 A's are here, and we got 4 A's over here, and so that's in common. So between these 2 here, what we have in common is this, which is a to the fourth. So that's where we got a to the fourth. And then where do we get b? Well, we have this b here, and only this b here, so we're going to have b. And so this is going to be our greatest common factor that comprehends all the a's and the b's. So that's how we got this over here. And then between this 2 and 16 and this 16 here, 16 is in common, a common factor of these. And so it's almost like these are going to cancel out these, and this will cancel out this, and what you have left over is that's a to the fourth, that's your greatest common factor, and then you have this and this, so you have a to the fourth b. I don't know if that in any way helped as an explanation. Probably not. Kaylee still has the mystified look on her face. Now, there's a little bit. Yes, go ahead.
Okay, so the ending part, the A and the 2 B's. That would be the second part of, right?
This here?
Okay.
Yeah.
So how do you get it if you do the long way? You do the 16 A for B first. So
Yeah.
you cross out the ones that have a common, and then your leftover is the one in parentheses.
Yeah.
Okay.
That's what you have left over. Okay. I don't know if that was much helpful. So anyway, she had the, here, is anybody, I don't know who, if more people are getting it or less people, I don't know. Who feels pretty comfortable looking at this? Anyone? Okay, Mason? Anyone here? No? Mason, the only one? Who feels very uncomfortable with this? Here, so several. So more levels of uncomfortability than comfort on this. I don't know, sometimes maybe we're just going to have to learn by doing and see if we can get someplace on this. Maybe that's the best I can tell you right now.
I think I did 14, but I don't know. Right.
14?
Yes.
Okay, then let's go ahead and go to 14 quickly. Let me go ahead and get this erased here. Okay, so 14, so looking at 14, we have x squared plus x. Now between x squared and x, what's going to be our greatest common factor between those two? X, right? So that's really, and then what times x is x squared? X. And we have plus, so that's going to go right here. So what times x is x? No. What times x is x?
1.
It's 1. So this is our answer right here. Okay? Let's go back here to,
It's pretty simple, we're just factoring binomials from polynomials, which is basically, you would know.
so here we have x squared plus x to the fourth plus x cubed. So between those three terms, what's going to be a greatest common factor? What do you say? X? No.
X squared.
X squared. Okay. Now, x is a common factor, right? But x squared is a greater common factor, we would call it greatest common factor, because x will not pick up everything here of this. So we can take x squared out of each one of these. So what times x squared is x squared? 1. So we have 1. What times x squared is x to the fourth?
X squared.
X squared. And finally, what times x squared is x cubed? Plus x.
Oh my God. I was thinking that.
So this will be our greatest common factoring, and I want to do one last thing. I'm going to rewrite this as x squared times, what am I going to do here next, you think?
Plus X squared.
I'm going to write it like this, x squared plus x plus 1. Standard form. Now, standard form, right. Now, there is one other thing you could possibly look for to do. It's possible that this thing here could be factorable also, and that you could factor this, because this is a quadratic expression. But as it turns out, this right here, x squared plus x plus 1 is not factorable. You can't factor it. Anybody know why or why not that x squared plus x plus 1 is not factorable? Because you can't, there aren't two factors I can make. If sometimes the quadratic binomials you can factor, the quadratic trinomial you can factor into two linear binomials. We can't do that here. So we're just left with what we have here. So this is going to have to suffice as our final answer for this one. But as far as the rewriting in standard form, did you see that? That should be pretty easy to do. Okay. Let's go on and look at number 4. Okay, on number 4, do you see any numbers that are common factors?
4.5.
Between 3, 4, and 5, are any common factors between those?
No.
No, so we can't really do anything with those numbers, can we? So we're just we won't be able to write another number here. Yeah, it's 1, but we don't write that down, right? Because we know 1 is a common factor, so we don't even need to notice that. So we're left with x to the 5th, x to the 4th, and x squared. What's the greatest common factor between the x things? X squared, right? So x squared is going to be, between these three things, our greatest common factor. And so what times x squared is 3x to the 5th?
3x squared, 3x cubed?
Yeah, 3x cubed. And then what times x squared is 4x to the 4th?
2x squared?
Yeah, so that's going to be 2x squared. And then finally, what times x squared is going to be negative 5x squared?
Negative 5x.
No? Negative 5.
Oh, my bad, though.
Okay? And so that's going to be that number 4 factored out.
Wait, isn't it, would it be just 2x to the 4th power?
Oh man, hey, I forgot something. I made a mistake.
Uh-oh.
Sorry about that.
No.
What mistake did I make? There should be 4 here.
Oh my goodness.
There we go.
Okay.
I don't know what happened here, but anyway, so now we're good. And what happened, I noticed, wait a second, where did that 2 come from? Yeah, this is going to be our common factor,
Yo.
our factor here. Okay? Is that what was bothering you, Kaylee, that 2 and that 4, is that what's bothering you? No, something else was bothering you.
No.
I don't know, I just can't understand it. It says 1, it says 2.
Yeah, you felt like that entire.
So Lillian, you understand what's going on here?
Yeah.
What about Mason? You're pretty good on this. Who else is pretty good on this?
Other than the whole.
Okay, through Chastity. So I want to say, as long as we're picking up some people, and we gradually can distill in our minds. Well, Ariana, you figure out what's going on here a little bit? Well, Brianna, you? No, get honest. Christine. Avery, what about you? Is this just slapping you upside the head?
Yeah, I
All right. What about you? Know what's going on pretty well, right? What about you, Garrett? No. What about you? Know pretty well? Okay. Well, it seems like I'm just Jordan, what about you? Figuring this out? No. What about Daisy? Daisy? Thinks pretty well? Well, just kind of polling around here, it seems like there's sort of a mix. So it seems like in the neighborhoods of where you are, there are people who at least are telling me that you have some level. Well, Colby, what about you?
I haven't even woken up yet.
Okay, so he's still trying to get in gear. Okay, let's go ahead to number 5. I think we're going to have to come back to this tomorrow too, some more.
I think Colby should do the next question.
Maybe Colby will sleep some more. Okay. Now we have 2x cubed minus x. So between 2x cubed and negative x, what's going to be, Chastity, the greatest common factor between those two, do you think? X, okay? So we look at that, and is everybody okay with what Chastity just told me here?
Yes.
We're good, okay? We're good on this. Everybody see why that's the case? Because x will be a factor of both of those things, and so we can do that. Is that going to be the totality of what our greatest common factor is here? Yeah, because the numbers, we don't have any numbers in common here, do we? So and the x is between those two, that's all we have to work with. And so now, what times x is 2x cubed?
2x squared.
Yeah, so 2x squared. And then what times x is negative x?
Negative x. Negative 1.
Negative 1. So we have that, and we have a quadratic binomial, so it would be possible to factor this, but this, we can't do that because that doesn't work. We're going to do difference of squares later on, and so this is going to be our answer for this one. That's as far as we can go. Well, Kaylee, you're seeing what's going on here? Kind of. Are there some light bulbs sort of turning on in the head a little bit here?
I think
Dave?
mine's broken.
You think your light bulb's broken? Yeah, it happens.
I gotta replace the switch.
Because to be honest with you, it's like I go into training in certain things, and I'll be at some concept. I took a course in linear algebra a couple summers ago, and it was one of those things that I just it had to settle in on me. So it happens to everybody. It's not, if you're at the right level. The right level is, hey, where can I get to understand of this? So for this one right here, and this, what are we going to have? And I'll just elicit a volunteer for number 6. What's going to be our greatest common factor here on number 6? A cubed, right?
Oh, yeah.
You got that? Kaylee, okay. Kaylee, is that you?
She said A3.
It's still the same thing.
I know I know what she meant. Okay, that's good. So now, and what about the numbers? We can't do anything in numbers, can we? So what are we going to have left over here from this?
3a squared.
3a squared, right? Was that you? Was that Kaylee? Was that you? Okay. All right. And then we have what's going to be over here? Minus 1. And so that's going to be it. Okay? So Kaylee sounds like she's settling in a little bit on that. I don't know, right?
Forget about it all tomorrow.
No, but that's the thing. Okay, now, as far as remembering things, there's sort of a principle somebody told me once. When you're trying to remember something, there's a principle of 10, 24, 7. If you can remember it again the next 10 minutes and 24 hours later and a week later, that helps most people get things more permanently.
Because it's
So-
like, the only thing that I'm struggling with is I understand where you're getting your answer, and I understand where it's coming from. I just don't know how to get started on it and actually
Okay.
figure out the how.
Yeah, getting started. And I think there's a lot of learning by doing on this thing, is what it amounts to. So anyway, that's where we have to end it today. Appreciate the class being here and attentive. I saw a lot of attentiveness today. That was good. Thank you.
I think Mr. G's gonna see my face most of the year, like,